So students, we start with the chapter Magnetism and Matter. In this chapter, we have to discuss about the magnetism and matter. As we know, matter, everything around us that is known as matter, and magnetism. Magnetism means here the property of attracting the iron or iron-like substance. Okay. So first we come to magnetism part. In magnetism part, as I already told you, magnetism means the property of attracting iron or iron-like substance, that is called magnetism. Okay. So if we talk about the magnetism, so property of attraction. So property of attraction of iron or iron-like substance is called magnetism. If we define the magnet, so magnet is to be classified into broadly parts: natural and artificial. Natural and artificial magnet. In natural magnets, Earth is called natural magnet. Similarly, lodestone is also called natural magnet. And artificial magnets are those magnets which are made by us, so made by human being. This is called artificial magnet. So in this chapter, we have to study about the magnet and their applications. So first we have to discuss the properties of magnet and how it is to be utilized in applications part. So first one property is to be there. It attract iron or iron-like substance, that is attractive property. Okay, because of it attract the iron or iron-like substance. Second one is directive property. That means it shows the direction north and south. That means when a magnet is to be suspended freely, its point out towards always north direction. Okay. Third one, if we make a bar magnet, so every magnet having two poles north and south. If we cut the magnet into number of pieces, so each part shows the two poles north and south, each part. That means every part of the magnet treated again a single magnet and it having two poles. Fourth one, in a magnet we have two poles north and south. So these two poles are known as pole strength. And this pole strength is to be denoted by M1 for first north pole, and for south pole it is to be M2. And the distance between them is to be taken, this is twice of L or L as per our convenient. Okay. So pole strength is to be denoted by M1 and M2. If we draw an imaginary line from north to south, so this is called axis of magnet. Okay, so this is called here axis of magnet. And fifth one is magnetic meridian. This is very important. So next one is magnetic meridian. In magnetic meridian, when a freely suspended magnet placed horizontally, so this is called here magnetic meridian. That means a vertical plane passes through a freely suspended magnet. For example, if I draw a diagram in which a magnet is to be suspended freely, that is north and south. So we have two planes. First one is horizontal and second one is to be vertical. So the vertical plane passes through the freely suspended magnet. This is known as magnetic meridian. Okay. So this is the key properties of magnet which are used in this chapter to study the magnetism behavior. So in order to experience the magnetic force, scientist Coulomb suggests one law that is called Coulomb's law in magnetism. So like electrostatics, when two charges are placed apart some distance, so there must be some attractive or repulsive force. Similarly here, when two magnets are nearby to it, so it also experiences some force. It may be attractive or repulsive, depends on the poles. If south and north is to be there, that means this force is to be attractive. Okay, and suppose this distance is to be r. So according to Coulomb's, this force of attraction or repulsion is directly proportional to pole strength, that is m1 and m2. If south pole having m1, similarly north pole having m2, so force of attraction or repulsion is directly proportional to pole strength. Second one, inversely proportional to square of distance between them. If we combine these two, so force is equal to m1 m2 with r square. Okay, and again whenever we remove this proportional sign, one constant is to be there. This constant is here k. F is equals to k m1 m2 with r square. But the difference is in electrostatic force and magnetic force, the behavior of the constant k. Here k is written as mu naught upon 4 pi and its numerical value is 10 raised to power minus 7. If we compare with electrostatic, so in electrostatic k is equal to 1 upon 4 pi epsilon naught and this equals to 9 into 10 raised to power 9. So this is the differentiation in Coulomb's law in electrostatic and in magnetism. In electrostatic, this identity is to be written as F is equal to K Q1 Q2 upon R square. So what we have to differentiate, Q1 is to be replaced by M1, Q2 is to be replaced by M2, and the difference is in constant also. In electrostatic, this is to be replaced by 1 upon 4 pi epsilon naught, and here this is mu naught upon 4 pi. So this is the difference part. Similarly, in electrostatic, we have to use for dipole moment P. Here again we have to use for dipole moment P, but the difference in pole strength and length. This is the difference part. Next we come to magnetic force intensity. So magnetic force intensity, that means how much magnetic force experienced by surrounding. In electrostatic we have to use E is equals to F upon Q naught. That means how much force is to be experienced by the test charge. In magnetic force intensity, this E is to be replaced by B symbol. Again, force upon charge. So this is to be replaced by force acting per unit pole strength. As I have already told you, Q is to be replaced by pole strength. That means magnetic force intensity means force acting per unit pole strength for magnet. And for every magnet we have two poles, north and south, and its pole strength is M1 or M2. So per unit pole strength, how much force is to be exerted, this is counted in magnetic force intensity. So in electrostatic, whenever we drive the derivation, same result is to be there, but only difference in their notification. When we calculate the magnetic field, electric field, at axis, similarly electric field at equatorial and work done. Due to rotation of dipole, so all the results remain same, only the difference is in their parameters. Example, if we axis, electric field is to be denoted by K Q upon R cube. So here we use E is to be replaced by B, K remains same, Q is to be replaced by M, that is dipole moment, and further R cube. For equatorial, this is E is equal to K 2M upon R cube, and here B is equals to K with 2M upon R cube. So here we define this M, dipole moment. In both the term electrostatic or magnetic field, this M is to be replaced. This M is to be replaced by P factor in electrostatic, and for magnetism it is to be replaced by capital M. Okay. So what we have to learn in magnetism and matter chapter, how to define the term magnetism. In magnetism we mainly focus on magnet part, what is their properties and how to utilize the property of magnetism in different applications, in diamagnetic substance, ferromagnetic substance and paramagnetic substance. And behavior is to be same like electrostatic. Thank you.